Hello, we are here for the last lecture of this part of the course that is related to the fundamentals of the Monte Carlo method. And we have studied the basics of probability distributions and the basics of the sampling statistical method, and then random numbers and random numbers generators. In the last class, we had random number generators and their main features that are important for taking into account when we decide which random number generator we will choose for our application. So let's review here the main features that we study and that are related to the Monte Carlo method. They are uniformity, periodicity, and dimensionality. So let's see how to test these features and check if they are appropriate or not for some of our applications. Now, what is the uniformity? Uniformity means that the resolution you have, or the smallest distance between the random numbers in your series, is not narrow or small enough. So you want events with a given resolution or separated by bins with some given width, and your random number series is not uniform enough. So they are separated, the smallest distance between random numbers is larger than what should be expected to get the resolution you want in your series of events. So let's say that we have a large distance between the random numbers, so the resolution is not good. And then what you have is random numbers that are the same in this period, in this range. You have just one random number, and this will give you just one event, and you would expect to have events in bins that are on both sides of this bin where you find your event. So when you build your event in this way with the wrong generator, what you have are bins like this that reproduce somehow your distribution, but they are separated by void bins, so bins that are empty. And this is not uniform. So you don't get the distribution you were expecting because you have some intermittency in the events. And this is not good usually. So you have to check for uniformity. And another one that you saw is periodicity, and we will see they are somehow related. Periodicity is when your random number series finish and start over again. So you get, at some point you get a random number in your series that you had before. So you reproduce all the events after this one, and this is also not good. So why they are related to the first one? Because if you have your random numbers in binary form, so a series of zeros and one, and written in binary form, you have L digits. So the number of digits is L. The resolution of your generator is 2 to minus L. This is the smallest distance for random numbers in your series, and the maximum period is 2 to L. So if you need more events than 2 to the power L, you have to look for another generator for sure. But of course, as we saw in the case of von Neumann generator, some generators will give you a periodicity that is even smaller than this one. So the fact that you have a high uniformity in your series does not ensure that your periodicity is high enough. You have to test. Fortunately, the LCG method of generating random numbers give you the periodicity of the series once you have the parameters A and M. So you can calculate it beforehand. So it's good to check that in your applications. If you don't do it, what you have, you generate a distribution. Let's say the bins are correct, they are uniform, but the periodicity is not correct. So at some point you start reproducing the same series, so you get histogram with a lot of events, but they are exactly the same. So this distribution is the same as this one. So what you have is a superimposed distribution, histograms of the same type. So this will not reduce the statistical errors in your sample. And you spend time generating and performing your Monte Carlo method, but it's not even improving our statistics. So just losing time and computational capacity. So for these characteristics, we have spectral tests, discrepancy tests that are theoretical. You can calculate them. And Q-square distribution, that is a statistical method. And also the other feature of random number generators is the dimensionality. It means that if you have a series of random numbers that are uniform and are not periodic, or the periodicity is larger than you need, but it seems okay. But when you use this series of random numbers to create vectors in some dimension, like dimension 3 here, so you use them to calculate R, the components X, Y, and Z of your vector, then you find out that they are not uniformly distributed, but they are displayed in like this. So there is some regularity in the distribution of points in this dimension. So this means that the dimensionality is not good. And we have lots of tests for these characteristics as well. You can use K-distribution or Kolmogorov-Smirnov method, least distance K-square distribution. I upload a text by Dr. Evandro Andrade II from the University of Santa Cruz in Ilhéus, Bahia. And you can look at it and the reference therein. This text is discussing these different methods and applications. It's in Portuguese, but the references are in English, so you can read it. And in the following, we will see how to use the Chi-square test for testing both uniformity and periodicity and dimensionality. It's quite easy test to perform, but it's very efficient.